The limit does not exist. The limit does not exist. The limit does not exist. Welcome back to Mean Math Girls, where I take the math problems presented in the movie Mean Girls and go over them. Let's see the final question.
Find the limit of this equation.
Evaluate the limit as x approaches 0 of natural log of 1 minus x minus sine x all over 1 minus cosine squared x.
Buckle up, this is going to be a wild ride.
Now to solve this, or any limit, we can first start off by plugging in 0 in for x and solving. So let's go ahead and do that. The natural log of 1 is 0. Anything to the 0 power is 1. And sine, let's look at this unit circle here. 0 is over here, so that point is 1, 0. Sine is the y value, so we have sine of 0 is 0. And on the bottom, 1 minus cosine squared 0. Well, cosine at 0 is 1. 1 squared is 1. So look what we have here. We have 0 over 0, which is what we call indeterminate, which means more work needs to be done.
What we can do now is try the L'Hospital rule. That allows you to evaluate limits when you get an indeterminate result by using derivatives. So we will take the derivative of the numerator, derivative of the denominator, and plug in 0. Let's see what we get.
So first, let's look at the rule of natural log derivatives. I'll write that off to the side. The derivative of any natural log of an argument. The argument is in the denominator, and the derivative of the argument is on top. So looking at that, we have the argument is 1 minus x, and the derivative of a constant is 0. The derivative of negative x is negative 1. Now the derivative of sine x is just cosine x. All right, so we did the numerator. Now let's find the derivative of the denominator. Again, the derivative of a constant is 0. Now we're gonna have to use the chain rule because we have cosine squared. Now with the chain rule, I'll write it out here. You use the normal power rule, swing the exponent out in front, keep what's inside the same, subtract 1 from the exponent, and multiply that by the derivative of what's inside. So we're gonna swing that 2 in front, we're gonna keep cosine x, then we're gonna times it by the derivative of cosine, which is negative sine. And again, all of this is limit as x approaches 0. So we can clean this up a bit. We have negative 1 over 1 minus x minus cosine x. All over, that denominator is really what we can clean up. We have negative 2 times cosine x times negative sine x. Well, 2 negatives in, multiplication is positive, so we have 2 cosine x sine x. Now we go ahead and plug in 0. Limit as x approaches 0. So we did a little bit earlier about what cosine 0 is. Negative 1 over 1 is just negative 1. And cosine of 0 is the x value at that point, which is 1. And then we have 2, again, cosine of 0 is 1, and sine of 0 is 0. So look what happens here. We have negative 2 over 0. Well, that is what we call undefined.
What we're going to do now is test the limit from the left and from the right of 0. The easiest way to do that is the calculator. Now we're going to input a test value, really, really close to 0 on the left and really, really close to 0 on the right. Let's see what happens.
Natural log of 1 minus, let's do negative 0. Let's put 5 zeros in there. 1, 2, 3, 4, 5, 1. That's super close to 0. And then we're going to plug in that for every x. Wow, look at that number. Super big. Let's say 4.58 times 10 to the 9th power, meaning you would move that decimal place 9 places to the right, which is really big. So we're going to say positive infinity. Now let's try it again to a very small value, super close to the right of 0. So what I'm going to do is just delete these negatives. And look what we get here. This time, it's same thing, negative 4.58, 10 to the 9th power, meaning we would move the decimal place 9 to the right, and it's super tiny. It is a small, small negative value, so we're going to say negative infinity. Now what does that mean? Let's look at the graph. Just what we expected. On the left side of 0, that graph is approaching what? That really big number here. It is going up, up, up to infinity, positive infinity. Now, on the right side, as we approach 0, where's it going? Down to negative infinity. Well, one side of the asymptote goes towards positive infinity, and the other to negative infinity. Then, dun-da-da-da,
The limit does not exist.
The limit does not exist.
the limit does not exist. So this problem is correct.